Hi, this is Jeff Spencer, Math 120 instructor for the Community College of Denver, and this is our video lecture over section 10b. Now in this section we won't get into everything, it's our last section, and we're just going to look at two things in here, similar triangles and the Pythagorean theorem. So we're going to start with similar triangles. Two triangles are similar if they have the same shape but not necessarily the same size, meaning that one is scaled up, one is a scaled up or scaled down version of the other. So the angles are the same, but the lengths of the sides are just different. So for two similar triangles, the ratios of the sides are equal. Okay, so the angles are the same. That's what we're saying here, and the ratios of the sides are equal. So if we look at the ratio from big C to little c, that's equal to the ratio of the big side A to the little side A. So we're going to use that to solve this problem here. So given that the pair of triangles is similar, find the length of the side labeled n. So we have this side 80, the ratio of that side to this side 80 over 20 should be equal to these matching sides, the ratio of 24 over n. So I can set that up in a proportion. 80 over 20, those two sides, is equal to 24 over n. And whenever we are solving a proportion like this, we can cross multiply. So I can do 80 times n, and that should equal 20 times 24. So 20 times 24, 480. So 480. And then to solve for n, we just divide by 80. So n would be, if I do, 480 divided by 80, 6. Okay, so the missing side is 6. Alright, so that's a pretty easy problem. You just solve it with a proportion. Got to remember to cross multiply. Okay, and then another type of problem we're going to do is the Pythagorean theorem. So the Pythagorean theorem is one of the most popular theorems in mathematics, and it involves a right triangle, a triangle who has an angle inside that's a 90-degree angle. That's what that little box down there for is, to reference a 90-degree angle. So for a right triangle with sides length A, B, and C, in which C is the longest side, or the hypotenuse, the Pythagorean theorem states the sum of the two sides, the two legs, squared, so A squared plus B squared, is equal to the square of the third side. So A and B are always referred to as the legs of the triangle. They form the L of the right angle, so they're the legs, and C is the hypotenuse. Alright, so let's look at this particular, gosh, I keep doing that. Let's look at this particular problem. So this is a slow pitch softball diamond is actually a square 61 with 61 feet on a side. How far is it from home to second base? So that's the hypotenuse of this triangle. So that means that this side is also 61 feet. So I have to do, let me write this out. This is going to be 61 squared plus another 61 squared, because that's the side of the other leg, or the length of the other leg, should equal C squared. Alright, so the first thing I have to do is get 61 squared and add it to 61 squared. So 61 squared plus 61 squared equals 7,442. So next line, 7,442 equals C squared. So to find out what C is, then I take the square root of 7,442. So I do second square root of 7,442, and that will give me the length of C, which is 86.267. Let's see what they want me to round this to the nearest tenth. So that would be 86.3 feet. Alright, so that's all we're going to do is just work these similar triangle and Pythagorean theorem problems. Good luck, and we'll see you next time.